Oh no. So good morning everyone, and as usual I would like to check that the video and the audio are okay. The video is not. It looks like there is a problem with the video. Okay, now we should be okay. So please, if you can confirm on the chat that you can hear me and see the slides. Unfortunately, the label of this class is still okay, thank you. The label of the chat is still space environment. I hope you will connect anyway. So we will wait another 5 minutes. I will make some announcements and then we will start. If you have any questions, please use the chat as always. Yes, I know, I know. Unfortunately, it's it's a mistake that I didn't fix, and I realized that only just prior to the to this class. So it appears a space environment, but it's related to the class that I will make. I will give right after this one at noon. So I will fix it later, and I hope this is not a problem for many of you to join. It's too late to correct. Okay, I think we can start. So, welcome back to all of you. Uh, we will complete the course with a section on radiometric measurements, therefore observable quantities for space navigation. We will say also something because many of you may not know about global navigation and positioning systems, especially from the system point of view, pointing out the need for time synchronization and the overall structure of the system. And we will talk also about ground systems. So this will be the topics of the next 2 weeks. In the final week, we will delve a little bit into system engineering, and I will give you some highlights on system engineering, on how space missions are run, and so on. So before we start, I received an email from the representative of students asking me to stop classes on time, which I do always, but I'm always available after class for a limited time for answering questions that you may have. So the space environment students asked me to do so and continue to do so. And what I will do is, of course, in the first quarter of an hour before the start of the class, I will be available to answer questions related to previous lectures or other question about the course, the exams, and so on. The same will be true in the interval, in the 15 minutes between the two lectures. And at the end, however, since there is always the possibility to require some clarifications, etc. I will also always and will continue to be available for a few minutes. Of course, you are completely free to leave the class at any time, and even when I close formally the lecture, you can go and attend the lecture given by a colleague of mine. So no problem from that point of view. But if there are some of you who need some clarification, I think is appropriate to give them right away. Of course, I will not stay for the full 15 minutes, for 5 minutes or so. If there are no questions, I will just stop and stop streaming. Pretty much the same thing that we were doing when we were physically present in classroom, where while waiting for my colleague to come in or to set up the computer, the video, etc., etc., I was available to answer questions. This is not an impediment to any of you to just quit and attend the classes right away from my colleagues. So let us start with this new module. This new module will tackle essentially with satellite TT&C, and TT&C is an acronym from telemetry, tracking, and command, which is a crucial part of a space mission. It's part of mission operation. mission operations, but of course it requires a careful design of the system. So we will give some definitions. Today it will be a relatively light lecture. We will give an overview of satellite communication systems, which most of you know from last year, but there are foreign students who did not follow the course on space telecommunication that was given at a bachelor degree. We will talk a bit about link budgets, and then we will delve into the Doppler range and angular observables and explain how these measurements are obtained from a ground station or on board. And finally, we will talk also about GNSS observables, global navigation system, satellite system observables. But we will do this by describing the system as a whole, and in particular looking at the system aspects of GPS-like systems. So we know that already about the main satellite or space mission categories. In Earth for missions around the Earth, we have communication satellites, which today are mostly TV system, although, as you may know, there are constellations with hundreds, really fleets of satellites being proposed for providing internet or access to the web from remote places. The commercial success, as I said, of these communication satellites is still to be seen. We remember always the failure of Iridium and Globalstar in the 90s, and also recently one of these companies failed brutally and went bankruptcy. So it has to be seen. But the communication satellites have specific requirements in terms of bandwidth, in terms of orbits, etc. So each of these has its proper requirements. Then we have Earth observation satellites, another category. We have weather satellites, which are a sort of Earth observation satellites. We have space research, planetary exploration, astronomy missions. We have surveillance satellites, and with surveillance we mean essentially we intend satellites for mixed civil military goals, and we have navigation satellites. Whatever mission we are dealing with, the radio link is the key, is the vital, is essentially a vital system. If we could, in a sense, make a comparison with the Earth body, I would say, is the nervous system of a mission. Because guidance, configuration, health management, in a sense, of a satellite is attained by means of a radio link. And how do we do radio links? Well, essentially today, mostly, almost exclusively, I would say, with radio waves, microwaves. And we will see the bands that we are employing. But there is a big push toward laser communication. Here I wrote laser tracking. Laser tracking is done today with certain classes of satellites, including the GPS-like GNSS satellites, for the purpose of orbit determination. But in the future, there is a big push toward optical radio links, which in principle promise a much larger data rate and therefore data return from a mission. We will not talk about optical comms, and we will treat laser ranging as a range measurement from obtained from radio waves. Conceptually, it's the same thing. And therefore, we will leave the optical part, although interesting and promising for the future, aside. So how do we receive and transmit signals to and from ground? Well, here you have a sketch of the two big segments that constitute a space mission. A space segment and the ground segment. The space segment is essentially the hardware and the software that is flying. The ground segment is all the infrastructure on Earth that supports, guides the satellite. And these facilities can be quite varied and rich. The basics are the radio link that are established. So here you see you have an uplink, and to establish an uplink we need transmitters. We have a downlink, and to establish a link on ground we need receivers. But you can imagine that also on the space segments you have the very same things. To receive the signal from ground you need a receiver, and to transmit data to ground you need a transmitter. So this structure, to a different scale of course, is replicated also on board the spacecraft. The ground station and the ground infrastructure is what decodes the telemetry, upload commands to the satellite, and can be said a sort is not really the control center of the mission, but is the control station. The control center, here you see this block in the diagram, a control station. The control station de facto can reside also very far away from the infrastructure where transmitters and receivers are located. And typically the control centers of space agencies resides in places that